Hello students, welcome to Learner's Planet, Theory Session 3 of Acids, Bases and Salts. In our last session, we discussed about the properties of acids, about its reactions with carbonates, with sulfides, with bisulphides, okay? So, sorry, I didn't discuss about the chemical reactions. I just told you about the reaction of metals with their sulfates, sulfides and bisulfides, right? So here it is giving you salt, water and sulfur dioxide. Now let's take a few reactions of this. Like your sodium sulfate reacts with sulfuric acid, forming sodium sulfate again, water and releasing sulfur dioxide. So here students, don't get confused that it is here there is sulfate in sodium, there is sulfate in H2SO4. So what should be the product form? The product form is the same, because here your sodium sulfate will give what type of ion, students? It will give you, say if I write here the types of ions which sodium sulfate is giving. Sodium sulfate is Na2SO4 and it gives you what type of ions in solution? It is giving twice of Na plus SO4 2 minus ions, right? And your H2SO4, what type of ions it is going to give in solution? It will give twice of H plus of SO4 2 minus ions. Got my point, students? So what will happen here is that your sodium will again combine with sulfate, any sulfate, okay? And one of the sulfates, from one of the sulfate, what will be released out is sulfur dioxide gas, okay? What will happen to hydrogen? It will form water, right students? So this is the reaction of sodium sulfate with sulfuric acid, giving sodium sulfate again, water and sulfur dioxide. Okay, so let's take up here the next example, that is zinc sulfide. Sulfite I told you is SO3 2 minus. Okay, now this is reacting with nitric acid, forming zinc nitrate, water and SO2. Now what are the types of ions which zinc is giving in the solution? Zinc is giving you Zn2 plus SO3 2 minus ions, right students? And your HNO3 is giving you what type of ions? H plus NO3 minus ion, okay? So what is happening here with between which ions the reaction is taking place? Zinc is reacting with nitric acid, forming zinc nitrate, okay? SO3, from SO3 what is released out is SO2, and this hydrogen is combining with oxygen of SO3 and forming what? Water, right? The reaction is just like the reaction with carbonates. In carbonates, what was the gas released? It was carbon dioxide, okay? With hydroxides, what was the product form? Water, right students? Reaction of metals with acids, what type of gas evolved is? Hydrogen. So what you have to remember is the gas or the byproducts which are formed with these compounds, okay? Now let's take up few more reactions of this, that is with bisulphides. This is NaHSO3, sodium bisulfide, reacting with HCl, that is dilute HCl. Now students, quickly tell me what all are the ions NaHSO3 is forming. Think about it. It will form what? Na plus HSO3 minus ion. Got my point? Now this HCl is forming H plus Cl minus ion. Okay, so where is the reaction taking place? This Na is combining with Cl, forming what? NaCl. Okay, HSO3, or out of this SO3, SO2 is released out. What is left here is hydrogen, one oxygen, and this hydrogen. This will combine and is forming what? Water. Okay, students? Now take this another example, potassium hydrogen sulfide or potassium bisulphide. What type of ion it will form in solution? I'll write it here. It will form K plus HSO3 minus ion. HCl will form what? H plus Cl minus ion. Now what all are the things happening? K plus is reacting with Cl plus, forming what? KCl, that is potassium chloride. Okay, students? From this HSO3, what is released out is S2 gas. And finally, there is one hydrogen, oxygen, and again a hydrogen ion, and it is forming what? Water. Okay, students? So in this way the reactions proceed. Remember, in ionic reactions, you should always try to ionize a compound so that it becomes easy for you to predict the products. Right? So if you start mugging up the reactions, it will become very difficult for you. You can't mug up 50 or 70 or 100 reactions. So just try to find out the tricks behind it, or just to try to find out the mechanism behind it. In case of ionic reactions, it becomes very easy to predict a product if you dissociate an ionic compound properly into a positive ion and a negative ion. Right? Let's take up another property of acids, that is action of acids on metal sulfides. Acids react with metal sulfides to form their respective salt and hydrogen sulfide. Okay, students? Now what is this here is again a sulfide ion. Right? So sulfide ion is, the formula of sulfide ion is S2 minus. Okay? So when I am saying metal sulfide, means if I'm taking a metal sodium, what will be the metal sulfide? It is forming Na2S. I am taking potassium, K2S. I am taking calcium, CaS. Right? I am taking lithium, Li2S. So this way the metal sulfides are formed. Right, students? So when this metal sulfides react with acid, what they'll form? They'll form salt and hydrogen sulfide. Okay. Say I'm taking this metal sulfide Na2S. Now this, students, your Na2S will dissociate, forming what? 2Na plus of S2 minus. Okay. And depending on the acid, whatever acid you are taking. Say I am taking an acid here as HCl. This will dissociate into H plus. So on what things it is going to dissociate? It will dissociate into H plus Cl minus. So where the reaction will take place, what will be the compound formed? It would be, or the reaction would be, Na2S plus 2HCl will give you what? 2NaCl plus H2S. Right? So what all are the compounds formed here, students? The compounds formed here are a salt. What is a salt? NaCl. And hydrogen sulfide. This is hydrogen sulfide. Right? Now let's take up some reactions of metal sulfides. That is, magnesium sulfide reacts with hydrochloric acid, forming magnesium chloride and hydrogen sulfide. Okay, so magnesium sulfide will be dissociated into, what will be magnesium sulfide forming? It will be forming Mg2 plus S2 minus. Okay, What will be your HCl forming? Tell me, what will be your HCl forming? H plus plus Cl minus. Fine. What will be your products formed? Mg will react with Cl, forming what? MgCl2. H plus will react with sulfide ion, forming H2S. Right, students? Taking up another example, that is iron 2 sulfide. Iron 2 sulfide is also called as ferrous sulfide. Right? Now this ferrous sulfide has the formula FeS. Okay? So what is it doing? This ferrous sulfide is reacting with what? With sulfuric acid. Okay? So ferrous sulfide is FeS. Now this ferrous sulfide is reacting with sulfuric acid and is forming FeSO4 and H2S. Your ferrous sulfide will be again dissociated into FeS, will be dissociated into Fe2 plus of S2 minus. Okay? Your H2SO4 will be forming 2H plus SO4 2 minus. Right? So where will be the reaction taking place? It would be taking place between Fe2 plus and SO4, sulfide and H. Right? If I'll put a cross here, it would be easy for you to do this thing. Right? So what all are the products formed, children, here? It is ferrous sulfate, that is iron 2 sulfate, and hydrogen sulfide. Right? So this is the action with metal sulphides. Right? Taking up another reactions of acids, that is action of acids on metal oxides. Right? As the name indicates, it is formed of oxygen. So acids react with metal oxides, forming respective metal salts and water. That is, sodium oxide is reacting with nitric acid, forming what? Sodium nitrate and water. Right, students? Sodium oxide and sodium nitrate. Now let's take up how this gets dissociated. Okay, how this gets dissociated? Your Na2O, that is sodium oxide, will dissociate forming 2Na plus of O2 minus. O2 minus. Okay, so this formula is wrong. What I have to write here is O2 minus ion, that is your oxide ion. Okay, children, so it is oxide ion, and HNO3, that is nitric acid. This will dissociate into H plus of NO3 minus ion. Right? So students, where the reaction will take place or how the product is formed, it is that your sodium reacts with nitrate, forming what? Sodium nitrate. Hydrogen reacts with oxygen, forming what? Sorry, water. Okay, so this is the reaction of acids with metal oxides. Right? I hope you got this. Let's take another example of a metal oxide, that is your if I take calcium oxide. So what will be the formula of calcium oxide? CaO. Okay, if I react this calcium oxide with what should I react? I'll take another acid, that is phosphoric acid, H3PO4. Right? So what it will form? It will form calcium phosphate, Ca3PO4 whole twice, that is calcium phosphate, and this is a salt. What all is left here, children? What all is left is hydrogen and oxygen. So it will form water, right? So oxides with acids form their respective salts and water. Fine. So these are some of the properties of acids. Okay. Now these acids have a corrosive nature. What do you mean by corrosive nature? Corrosive means they react with the metal and they form their respective oxides, and in the form they corrode the metal, right? So they are never stored in metal container as they corrode or eat up the metal container, right? So where are acids stored? They are stored in ceramic or glass containers. You know, students, glass has got the toughest bond, right? So the glass is made of what? Silica. So this silica has got the toughest bond. You know the chemical composition of glass? This is sodium silicate, Na2SiO3. This is a basic compound which is present in glass. Together with it, to provide it color, some zinc, some chromium is added or some manganese is added to make it colored. But the basic compound here is silicate. Okay, and the silicate bond, students, is very, very tough bond, right? Silicate bond is a very strong bond. Right, students? So therefore this acids, they don't have effect on the silicate bond. Okay, so the only acid which can break silicate bond, cleave, or I can write break silicate bond, is HF, that is hydrofluoric acid. Right? Now you know that etching of glass. What do you mean by etching of glass? It is writing on a glass. Okay, so you must have seen Borosil containers or Borosil beakers, your pipettes, burettes in your laboratory. In that there is some markings written there, say 2.5 ml, 25 ml, 50 ml. Those markings are done with the help of hydrofluoric acid. None other acids can destroy or cleave the silicate bond. Got my point? Now the question is, where is this hydrogen fluoride stored? We know that this is a Ghana acid. We can't store it in a metal container. We can't store it in glass also, because this is breaking up the silicate bond. So where it should be stored? Now students, it is stored in a glass container only, but there is a wax lining on the glass container, right? So it is stored where? It is stored in wax lined glass bottles, right? So this is some additional information which I wanted to give you, right? Okay, so these are about the acids and their nature. Now we will see about the electrical conductivity. Electrical conductivity means the substances which can carry electric current are called as what? Electrical conductors. Say acids. Your solution of HCl, that is hydrochloric acid in water, conducts electricity. Now why it is conducting electricity? There is a very simple thing, students, which you might be knowing, that the electrons are the electrical conductors, or the charged particles are the electrical conductors. Got my point? So here, in this case, if HCl is dissolved in water, what is happening? It is giving what all cations and anions? H plus and Cl minus. How? Why they are produced? They are produced due to dissociation of acids. Now these carry electric current. Got my point, students? So that is why your hydrochloric acid in water is a good conductor of electricity. Okay, students? Now, aqueous solutions of sulfuric acid, carbonic acid, phosphoric acid conduct electricity as they produce cations and anions. Now let's take sulfuric acid. What type of ions this sulfuric acid is forming? Tell me. It is forming hydrogen ion and sulfate ion. Right? What type of ion your carbonic acid is forming? That is H2CO3. It is forming again hydrogen ion and carbonate ion. What type of ion this phosphoric acid is forming? That is H3PO4. Hydrogen ion plus phosphate ion, PO4 3 minus. Right, students? So these all are forming what? These all are forming ions. Okay, so this is thrice of H plus. So now these ions are good conductors of electricity. Now you just decide one thing, that I'll take another example here, that is HNO3. This will give you H plus plus of NO3 minus. Of these, which would be the best conductor of electricity? The best conductor would be, students, the one which furnishes more number of ions. That is your H plus and sulfuric acid. These are the one which is furnishing more number of ions. The phosphoric acid, it is furnishing 4 ions. Okay, your carbonic acid. Carbonic acid is a weak conductor of electricity. Why? Because its dissociation is partial dissociation. Okay, likewise your other acids like acetic acid or your vinegar. Acetic acid is CH3COOH, right? Or your citric acid, or another some organic acids. They undergo partial dissociation, right? So when they are undergoing partial dissociation, what will be their electrical conductivity? It would be less, right? Why less? Because they are furnishing less number of ions in the solution. Got my point? So acids are the conductors of electricity in water. Now students, what about dry HCl? Will it conduct electricity? No, it will not conduct. Thus, acids, they produce ions in their aqueous state, but in their solid state or the dry state, they are not producing any of the ions. Okay, students? So when they are not producing any of the ions, how can they conduct electricity? Right? You must have heard of that rainwater, that is acid rain. Acid rain means that the rainwater consists of acid particles in it or acids in it. Now rainwater is a very good conductor of electricity, whereas your distilled water is a non-conductor of electricity. Why? Because distilled water has no ions in it, whereas rainwater has ions in it. Okay? Now let's take up another point, that is compounds like alcohol, glucose do not conduct electricity in their solution form, though they contain hydrogen atoms. Right? I'll write the formula of glucose here. Glucose is CHO, CHOH whole 4 and CH2OH. This is what? This is glucose. And alcohol, let's take normal alcohol or ethyl alcohol. It is C2H5OH. It is C2H5OH, that is ethyl alcohol. Now why I am writing this formula? This is because they are containing what? Hydrogen atoms. How many hydrogens are here? 1. And it has got so many hydrogens, right? 8, 1, 9, 9 and 3, 12. These have got 12 hydrogen atoms. But still it is a non-conductor of electricity. Why? Or this ethyl alcohol has got 6 atoms of hydrogen. Still it is a non-conductor of electricity. Why? Because this glucose and alcohol, what are they not doing? They do not produce hydrogen ions in solution, right? Because why they are not producing ions? Because they are not ionic compounds. So these are not ionic compounds, okay? What type of compounds are they? As these are not ionic compounds, they will not give any ions. What type of compounds are they? They are covalent compounds. Right, students? So these are what? Covalent compounds. Now they are not giving any type of ions in the solution, so they are non-conductors of electricity. Got my point? Now let's take up bases. How they behave. Bases. Some bases are good conductors of electricity. Again, for conduction of electricity, what is required is ions. Now these bases, soluble bases like sodium hydroxide and potassium hydroxide produce hydroxyl ions or hydroxide ions, OH minus ions in water. Okay, they dissociate completely to form ions. These ions carry electric current, like your NaOH is dissociating to form Na plus and OH minus ions. Now here also, students, if I take another base, that is NH4OH, this is a weak base. Weak base means it is undergoing what? It is undergoing partial ionization. Now what do you mean by partial ionization, students? Partial ionization means the ionization is not complete. The ionization is a reversible reaction. Okay. So this is undergoing partial ionization, right? This is undergoing partial ionization, that is the reaction is reversible and it is forming NH4 plus of OH minus ions, right? Now in this case, students, which will be a good conductor of electricity? Base which is a stronger because it is giving more number of ions. And a weak base will be a poor conductor of electricity because it is giving less number of ions. Right, students? So, for this session, I'll conclude now. In this session, we discussed about the reactions of acids with different compounds and also about the electrical conductivity. Right? So, whenever there is a question asked about this compound, say your citric acid is a good conductor of electricity whereas distilled water is not, what will be your answer? That citric acid produces ions in solution whereas distilled water is not producing, do not contain ions. Okay, so as it is not containing ions, it would be a bad conductor of electricity. Your rainwater is a very good conductor of electricity. So students, just whenever there is such type of question asked, you move into its into the type of compound it is, whether it's an ionic compound or it's a covalent compound. If it's an ionic compound, it would be a good conductor of electricity. If it's a covalent compound, it won't be a conductor of electricity. Okay, and depending on the degree of ionization, that is whether it undergoes complete ionization or it is undergoing a partial ionization, the conductivity is decided whether it would be a good conductor or a weak conductor of electricity. Okay, suppose we have got we are also good conductors of electricity. Like electricity can pass through our body. Why? Because there is lot of salts in our body. The salt is NaCl. There is again ionic, and that conducts electricity in our body. Okay. So these are the things which we discussed in our session, and in the next session, students, just I want you to just go through bases so that we can discuss the properties of bases in our next session.